Hello everyone. In the last session, we have seen the introduction part of Python programming. In that session, we have seen who is the creator of Python programming. After that, we also discussed at which center Python programming language was developed and how the name Python was given to the programming language. After that, we have seen what was the first release of Python programming. This is about the introduction part. After completing the introduction part, we have seen what is the need of studying Python programming and what actually a Python is meant for. We have defined that a Python is an interpreted, multi-paradigm, general-purpose, high-level programming language with easy syntax and dynamic semantics. We have discussed what do you mean by the interpreted language. After that, we have discussed about multi-paradigm and also general-purpose high-level programming language. In today's session, we are going to discuss what actually mean by the simple syntax or easy syntax. After that, we will see the dynamic semantics. See, let us discuss about the clear syntax or easy syntax and next dynamic semantics. First, we are talking about the clear syntax. Let us take the variables here. Integer x is equals to 5. Integer y is equals to 6. Here I am writing printf percentage d double quotes close comma x plus y. This is the simple C code. What type of code it is? High level code. We will discuss in detail what do you mean by high level code. High level code means we are talking about high level programming language. So we are instructing the computer or we are giving a set of instructions to the computer in human readable form. That is known as the high level code, or we can say high level programming language. Example here we are taking is C code. In the first statement, we are defining that x is an integer. Okay, at the starting stage, before execution, we are strictly instructing that x is an integer and whose value is 5, and y is an integer whose value is 6. And printf percentage d is some format specifier we are giving, and we are saying x plus y. This is a simple code, and if you execute this, the output will be 11. Now, the same code I am writing in Python. This is C code, and here I am writing Python. In Python, just we are writing x is equals to 5, y is equals to 6, and just instead of using printf, just we are using print in bracket x plus y. If you observe this statement, here we have mentioned that x is the type of integer and is equals to 5, and after that, after every statement, we are keeping semicolon, which indicates the end of the statement. Here, there is no integer and there is no semicolon. No need to declare the variable x as of type integer, and there is no semicolon. If you take the second statement, here also we have declared y as of type integer, but here there is no declaration, there is no semicolon. Here in printf, printf is somewhat difficult to understand what if f stands for. But here there is no f, simply we write print. Print and printf, if you observe these two statements, print is somewhat easy to understand compared to printf. And here we have written percentage d, but here there is no percentage d. Just we are printing x plus y, and there is no semicolon. If you observe the C code and Python code, this is the Python code. If you observe this Python code, it is very easy. There is no data type, there is no semicolon. Very easy to understand. We have clear syntax, simple syntax, easy syntax. So this is the greatness of Python programming, or we can say Python code. Now coming to dynamic semantics, what do you mean by the dynamic semantics? Remember, semantics always represents the meaning, logical meaning, or simply we can say meaning. Syntax refers to the structure or format, whereas semantics represents the meaning. Here, when you consider the C code, there are no dynamic semantics, dynamic and static. We will discuss what is mean by static and what is mean by dynamic. There is a difference between static and dynamic. If you observe this static, C uses the concept of static, whereas Python uses the dynamic concept. What do you mean by static? Static in the sense, before runtime or before executing the statement integer x equals to 5, we are saying that before execution, we are referring that x is of type integer. That means x always going to contain only the integer value. Next, we are also saying y is of type integer, means y is always going to contain 6 only. After this statement, if you try to give the value x equals to 5.67, then even though you give the value 5.67, it takes only 5 and that is stored in the x. Why? Why? Because at runtime you are providing the value 5.67, but before execution at compile time or at static time, you have given that x is of type integer. You have already predefined that x is integer, y is integer. After predefining everything, if you try to store x equals to 5.67, 0.67 is truncated, only 5 is stored in the x. This is about static typing. But if you take the Python code, see here x equals to 5. Here we didn't mention x is of type integer. If you take 5.5, automatically x is going to store the float value. We have not fixed the type of x here. Similarly, we have not fixed the type of y here. Now, if you say before printf statement, if you try to store x equals to 5.78, then it is going to take float value also. So at later time, if you provide the different value, that different value becomes the new value. Why? Because so sometimes it is going to store integer, sometimes it is going to take the real value. Why? Because we have not predefined the type of x here. Dynamically, x value is going to change. You can give integer value, you can give float value, you can give string value, any type of value you can provide at runtime. But this could not be possible in C code. So this is a good example for the dynamic syntax. I think it is clear about clear syntax and dynamic semantics. Next we will see. Now we will discuss about translators. What do you mean by a translator? See here, before moving on to various types of translators, let us have some discussion about translators. Assume that this is the system and he is the user, right? Here we are talking about the communication between the user and the system. This user wants to communicate with the system. So for this communication, we need a language. When the user wants to communicate with the system, the user needs a language. That language we are calling it as high level language. High level language. That means the user is going to give the instructions to the system by using high level language. That is very, very important. Okay. But coming to the system doesn't know about high level language. It is unable to understand. The system is unable to understand the high level language. The system knows its own language. What is that language? That is known as machine language, or we can say low level language. Machine language, in the sense, we are calling it as the binary language. That is, in the sense, zero signed ones. Here, the problem is in understanding. The system knows machine language, the user knows high level language. That means the system doesn't know high level language, the user doesn't know machine language. Here, the problem is communication gap. How to resolve this? You can ask one doubt, why the user is not able to write the program in binary language? Why? Because binary language means everything is zeros and ones. It is impossible to write the program to give the instructions in the form of zeros and ones. That's why the user is going to select easiest language, which is somewhat near to English. That easiest language is called high-level language. After writing the program or the instructions in the high-level language, the translators come into the picture, and these translators are going to convert the high-level language program into machine language. That is the main objective of the translators. Now, translators are nothing but the software components. Very, very important. What I'm saying, translators are the software components which are going to convert high-level language code, or we can say simply the source code, into the binary language code, or we can say machine language code, that is in the sense zero sign ones. For this conversion purpose, we use the concept of translators. Already in the previous classes, we discussed that when we use the concept of compiler for compiling the source code into executable code, those languages are known as compiled languages, right? When it uses the concept of interpreter to convert the source code into object code, that is known as interpreted language. That means if the program, if the system is going to use compiler, then that is known as compiled language. If it is using interpreter, that is known as interpreted language. What I mean to say here is, mainly we are talking about the two type of translators. First one, we are talking about the compiler, and second one, we are going to discuss about interpreter. This is the basic introduction about the translators. The main purpose is to convert the high-level language program, that means source code, into machine-level code or binary language code, or we can say zero sign ones. That is the main intention of translators. Why we need translation? Why? Because the machine does not understand the user instructions or high-level language code. So for understanding purpose, there is a need to convert the high-level language program into the machine level. That is the main intention of using translators. Now we are going to discuss first what is mean by a compiler. This is very, very important. Take a system. Here I am taking a system. This is the system of Alice, right? And here we have a system, another system. This is the system of Bob. On the system, Alice system, we are writing some code. That code, assume that 4 lines of code is there, that we call it as the source code. In which language it is? It is in high level language, right? We have some source code on Alice mission. Now this Alice mission is going to use compiler. Here we are talking about the compiler. Now the role of this compiler is, at a time the compiler is, at a time in the sense, how many instructions? 4 instructions are there in the source code. At a time all the 4 instructions are converted into the machine code. That means zero sign ones. This is the first one, this is the second one, and this is third one, and this is fourth one. See, this is the code generated by the compiler at a time by converting the 4 lines of statements, or we call it as the source code, which is written in high level language, and it is converted into binary language. The code which is generated in binary, we call it as executable code. Okay, here we have converted the source code at Alice by using the compiler at Alice, and it has generated the executable code, or we can say machine code. This is the machine code or executable code generated at Alice. Now you can execute the same executable code at Alice system, or assume that Alice does not want to execute this executable code, and assume that Bob wants to execute this executable code. Bob is using another system, right? And assume that one important thing here is Alice has used the system whose operating system is Windows. When it has used the Windows, the extension of the executable code is, that is generated, is .exe executable file. Very, very important thing you note down. The extension of the executable code on the Windows machine is .exe. If you use any Mac operating system, we are going to get the extension .app. But we are not talking about app. That means we are not using Mac. Assume that the Alice system is Windows system and the executable code generated is .exe file. Once the executable code is created at Alice, this executable code can be used by any machine. Here assume that the Bob wants to use this executable code, and Bob can execute this executable code without having compiler here. The Bob system is not going to use any compiler. We have used only the compiler at the Alice machine. Bob doesn't require the compiler to execute this executable code. Bob can automatically execute this executable code without using the compiler. But the thing here is the Bob system must support only, there must be only Windows operating system. Then only this executable code can be executed on the Bob machine. Why? Because so at Alice we have used the Windows operating system. So the Bob also should use the Windows, right? So on any machine, this executable code can be executed, but the only thing here is the systems must have only Windows operating system. Why? Because the executable code has the extension .exe, which was created by Alice by using the Windows operating system. This is very, very important. That means when you use the concept of the compiler, the code that is executed, generated executable code is not portable. Please remember, it is not portable. Portable in the sense, for example, assume that we have another system, not only Bob, you take another system, John system, which is using the operating system Mac. This executable code, which has the extension .exe, cannot be executed by the John machine who is using the Mac operating system. Why? Because we have different machines with different operating systems. This executable code cannot be executed on different operating systems. So when it is executed by the different operating system, then only we would say it is portable, but it is not portable. So this is the scenario of using the concept of compiler. Now coming to the interpreter, what do you mean by the interpreter? See, in the interpreter, assume that we have a same system. Assume that Alice has written the code. How many instructions? 4 instructions. The operating system here he has used, assume that Windows. Now here we are not going to use any concept called compiler. See, the main difference between the compiler and interpreter is in the compiler, when you use the compiler, the conversion is done before runtime. At compile time, we are going to create the executable code. But here, when you use the concept of interpreter, there is no compile time. There is only runtime. If the conversion takes at runtime, that is known as interpreter. If the conversion or translation is done at compile time or before runtime, that is known as the compilation or compiled programming language, that is known as the compiler. See here, previously I said that the source program is converted into executable code, but here there is no question of executable code. Assume that there are some systems here. This is one system and this is another system. Here we have 3 other systems. If this code wants to be executed by these 3 machines, there is no need of converting the source code into executable code. The copy of the source code directly provided to these systems. The copy is passed to this system and one copy is passed to this system. So directly we are passing the source code. If this source code wants to be executed on different machines, Alice is just sending the copy of the source code to the multiple systems, right? And these multiple systems should have their own interpreter. Please remember, their own interpreter must be installed at these systems. Previously, I said that there is no question of using the compiler at a Bob machine. Why? Because once executable code is created, that is automatically executed on various machines using the same Windows operating system. Their compiler is not required. But here, we are not generating the executable code. Just we are going to execute the code, source code, at runtime by using their own interpreters. And what this interpreter is going to do, it is going to take the source code and it is going to convert the line by line into machine code. First, it takes the first line on the fly at runtime, and first instruction is converted into machine code, and it takes the second one. Everything is done only at on the fly, right? Directly one by one, directly runtime. There is no compile time. There is okay on the runtime only. Everything is converted into machine code line by line, and we are going to get the output. But here, different machines must have the interpreters, though they have different operating systems, Windows, Mac, or any other operating system, Linux. See, here we are talking about the different operating systems. Different operating systems can execute this same program, same source code by installing the proper interpreters. This is possible at runtime. This is known as portability. But this is not true when you use the concept of the compiler. I think there you have understood the difference between the compiler and interpreter. In compiler, the translation will be done before runtime, whereas in the interpreter, the translation is done at runtime. In interpreter, line by line conversion is done. There is no question of converting the source code into executable code in the interpreter, and the destination machines should have their own interpreters. But this is not the case. In the next class, we are going to see what are the advantages of what do you say interpreter, disadvantage of interpreter, and advantages of compiler and disadvantage of compiler. With this, I'm going to close the session. Thank you for watching.